Here are the answers to your 5 a day. Let me know if you have any questions about it. Just pointing out for question 5 here, on the front of most of your test papers, it does say that all denominators need to be rationalised. So while both of these are perfectly acceptable ways of writing this number, do make sure that you're providing answers in the way you have been told to on the cover page of assessments. Okay, so today we're going to be looking at how to represent complex numbers on a diagram. These diagrams are called Argand diagrams. We're also going to have a look at some geometric interpretations of some calculations with complex numbers. So, where we use a grid with x and y, plotting those coordinates are known as a Cartesian set of axes after the mathematician and philosopher René Descartes. An Argand diagram looks the same, but the x-axis is now called the real axis and represents the real numbers, and the y-axis is called the imaginary axis and represents imaginary numbers. We can plot complex numbers on an Argand diagram just the same as we plot coordinates. So let's have a look at these 3 complex numbers and what they look like on an Argand diagram. Here's our axes. See, instead of x, I've got real part of z, imaginary part of z. Because all of these numbers are up to 5, that's what I've labelled my axes as. So, z1, 2 in the real direction, 5 in the imaginary direction. That's up here. z2, 3 in the real direction, -4 in the imaginary direction. z3, -4 in the real direction, 1 in the imaginary direction. When you're plotting these, so you don't have squared paper, but you do need to make sure that the scale works. So Z1 being 2 on the real axis should be half the distance to the imaginary axis as Z3, and so on. You need to make, even though you don't have your squares, you need to make your scale accurate. So now being asked to find the magnitude of OA, OB and OC, where O is the origin and A, B and C are Z1, Z2, Z3 respectively. So for this we're going to use Pythagoras Theorem. This distance here is OA. I go 2 across and 5 up, so the magnitude of OA is the square root of 2 squared plus 5 squared. I can simplify that to the square root of 29, which I can't simplify any further. So root 29 is the magnitude of the complex number 2 plus 5i. Z2, that's 3 across, 4 down. So the magnitude of OA, or Z2, is the square root of 3 squared plus 4 squared. Hopefully you should notice that's 5. And note that I'm using positive numbers for both of them because we're just measuring distances. And for Z3, we've got 4 and 1. And so the magnitude of OC, or Z3, is the square root of 4 squared plus 1 squared, which is root 17. Pause the video now while you have a go at questions 1 and 2. And here are your answers. Okay, so here are 2 complex numbers. I've got to show both of them and their sum on an Argand diagram. Let's work out their sum first. I need to collect the real parts and collect the imaginary parts. Then here's my axes. Z1 is 4 plus I. Note my scale, this goes to 10i, so I'm only doing half a square there. Z2, 3 plus 3i. And their sum, 7 plus 4i. Now, if I draw lines in, you might be able to see that the vector z1 plus z2 is effectively the diagonal of a parallelogram. Let's have a look at another example. This time, though, we're finding the difference between them. So be careful with your subtraction. Make sure you write the second one in brackets so you don't miss out any negatives. And our difference is -2 plus 3i. We plot these on an Argand diagram. Here's z1, here's z2. This time, here's z1 minus z2. Now, this is still it's not the diagram, is it? It's the diagonal of a parallelogram. But this time, the sides of the parallelogram are z1 and negative z2. Pause the video now while you have a go at question 3. And here are your answers. Here is a complex number. We're going to show the complex number multiplied by -1, and the complex number multiplied by I on an Argand diagram. So here's z1. If I multiply it by -1, I get -2 minus 5i. That's here. Have a think about what that looks like. If I multiply it by I get this. I'm going to expand the brackets. I'm going to simplify because I squared equals -1. I get this complex number, which I can plot here. Have a think about what that looks like. So what we can say is that when we multiply a complex number by -1, for its point on an Argand diagram, it results in a 180-degree rotation about the origin. If we multiply a complex number by I, it results in a 90-degree anti-clockwise rotation about the origin. Just realise that this point is in the wrong place. This should be here. Now have a go at questions 4 and 5. Here are your answers. Let me know if you have any questions. Thank you.